Hello, hello. I have a little demonstration for a project that I worked on yesterday, and for the most part, it is completely working. And I'll just show you what I am doing this on. Back at the NBCU hackathon here in Orlando, Florida, the team that I was on worked with iBeacons that could query an SQL Azure database to allow credential entry. I repurposed the actual beacon part of that code to create a networked-iBeacon. And I'll give you a quick demonstration, but first I'll show you what I'm currently using. This is a Raspberry Pi. It's a darling in the IoT community. And we have a Wi-Fi antenna here and a generic BLE USB dongle. And this is running Raspbian and running the Python program. And I am also using an Intel Edison. Now, if you're not familiar with the Edison, and you might be a little bit intimidated by this whole board, the actual Edison is this piece right here. This is the entire Linux on a chip with built-in Wi-Fi and Bluetooth. The rest of the board is a breakout board, so it can be used with Arduino shields. But the actual chip that that's working on is actually confined to this component right here. And both of these are being powered by a good-sized 2-amp power supply here via USB. Now, both of those are on the network. They have IP addresses, and I have already set up the beacons running on them, and you can see here. I have not yet made a distinguisher between the two, because they are both using the default values embedded in the file. However, we're going to fix that, and I'll show you how. First off, I'm going to show you how we change the values by showing you this. This is the included CSV file that comes in the repo, and it's just an example of how you might set up this particular CSV. It's divided into a couple sections. First off, we have the IP address, and this particular IP address is associated with Pi. Then we have the company ID, the long hex string that each company registers. Then we have the major value, which is an int, an integer. We have the minor value, which is an integer, and we have the power, which is an integer. If you don't know what these values mean, look up the iBeacon spec. It's pretty straightforward. It's just the numbers. The company might be associated with Universal, a particular. Let's use the department store. Say Macy's applies for a company ID, and they get it. Each major value might correspond to a particular department store. The minor value would correspond to a particular beacon within that store. And then power is used for calibrating, because beacons can also be used to determine distance from the beacon. So we have it set up so that our first IP address over here is our Pi. The second one is our Intel Edison. And the third one doesn't actually exist, but it's in there because I want to show what the code can do. So when we run a controller program, the Pi will be set major 0. The Intel Edison will be set major 1, and this one should fail. And just to give you a little bit more, show what else is going on the screen. This here is, we're currently SSH'd into the Raspberry Pi over here. And we can see that the beacon is currently up with our default major and minor values in here. And over here we have the Edison with the same default major and minor values. Up here we have, we're in our folder, and we're going to run controller.py. And so we see while it's waiting to time out, it went through the Pi, went through the Edison, and then it is attempting to connect to our IP that doesn't actually exist. And I'll probably go ahead and change the timeout so it doesn't take quite as long. And we can already see down here that that the Pi it says iBeacon has changed. We didn't actually update the values for the Pi, but over on the Intel Edison we did. So now our major value is indeed 1, and our minor value hasn't changed. So I'm not entirely sure. It might actually have a default timeout of 30 seconds. I'll go ahead and fix that. But we'll go ahead. When we're done, it gives us a report for a total of 3 beacons, 2 updated successfully, 1 failed, and then it gives us the IPs of all of the ones that failed. So if we want to go in and change, for example, if you have a couple beacons set up at Halloween Horror Nights at Universal Studios that cause blood splatter to appear on people's phones, and you repurpose those beacons for the Mardi Gras parade as people are walking by, you probably don't want them to have the exact same beacon value, otherwise blood splatter is going to appear during the Mardi Gras parade. So let's go ahead and give an example. We're going to set our minor values over here to, let's say we're both going to change them to 50. And then our third one there isn't actually going to do anything. So we'll go ahead and save our CSV file and rerun our controller. And we can see down here, well, let's go ahead and time that out. 2 updated successfully, 1 has failed. Our Pi down here, we can see indeed we have still a major value of 0 and a minor value of 32 in hex, which is 50 in base 10. And then over here, same thing, we have major value of 1 and a minor value of 32 hex, which is again 50 in base 10. So this is an example of the values of iBeacons being changed over a network connection by doing a batch reset or a batch update. So you can imagine overhauling every network connected iBeacon in a store or an amusement park just by running this program, and you wouldn't have to go out and change anything. And because the iBeacon is running on a Linux system, there's opportunities for all sorts of further applications, things like hardware integration and so on. And so I'll get that timeout fixed. And I also want to mention that right now I don't have any remote shutdown features in here, but every single time that the values of the beacon are changed over the network, they are saved to a local CSV file that gets read the next time that the iBeacon changes. So the default values in the file will only be used if there's no locally saved file previous values. So they do store persistently between sessions. Well, that's what I have. There's a couple tweaks left, but this is mostly intact, and it's no more than about 150 lines of code total. So it's nice, small, and compact. It's running Python.